Today we're going to talk about the Pythagorean Theorem and its converse. You should be on page 25 in your notes packet. Before we get started, let's talk about some important vocabulary that we have when we're talking about right triangles. In a right triangle, we know that it is a right triangle because one of the angles is a 90-degree angle. The sides of right triangles have specific names. The two sides that are adjacent to the right angle are called legs. Your legs are your two shortest sides of your triangle. And they are adjacent to the right angle. The side that is opposite of the right angle is called the hypotenuse. So the hypotenuse is always the longest side of the right triangle, and it is opposite of the right angle. The Pythagorean theorem says that in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So that sounds confusing, but let's look at this. The easiest way to write this is in the formula a squared plus b squared equals c squared, where a and b are legs and c is the hypotenuse. In this triangle, we can see that it would be a right triangle, and we can see that this one has a side length of 3, this one has a side length of 4, and this has a side length of 5. Even if we did not know that there was a right angle right here, because it doesn't actually tell us, if we know that this is a right triangle, we know that this side over here would be considered the hypotenuse because it is the longest side. Now let's see why this works. When we have a side length right here of 3, 3 to the second power gives us 9. So you can see here that we have a square that comes off the side of this that has an area of 9 units. Well, 4 would be our next leg. If we have a square that has a side length of 4, then the area of that square is 16. Well, that is the same as 4 to the second power. Well, all of this is going to be equal to the hypotenuse squared, which is 5. And we know that this is true because 5, if we have a square that has a side length of 5, then that square has an area of 25. If we plug all of that in, 3 squared plus 4 squared equals 5 squared. 3 squared is 9, 4 squared is 16, and 5 squared is 25. If we do 9 plus 16, we get 25. So we know that this works, and that is what the Pythagorean theorem tells us. So the Pythagorean theorem really is this formula a squared plus b squared equals c squared. A Pythagorean triple is a special set of integers where you have a, b, and c that would satisfy that equation a squared plus b squared equals c squared. So what we just saw, 3, 4, and 5, is considered a Pythagorean triple because 3 squared plus 4 squared does equal 5 squared. It doesn't always work. So if I said 1, 2, and 3, well, I know 3 would be the hypotenuse, so I would do 1 squared plus 2 squared, and I would see if it equaled 3 squared. Well, 1 squared is 1 times 1, which is 1. 2 squared is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. Well, 1 plus 4 is 5, and since 5 is not equal to 9, I know that 1, 2, and 3 is not actually a Pythagorean triple. Identify the unknown side length as a leg or hypotenuse and solve for x. Round to the nearest tenth place if necessary and tell whether it is a Pythagorean triple. Well, in this problem, you see that we're missing x. X is opposite of the right angle. Since it is opposite of the right angle, we are missing the hypotenuse. Now we can figure out how to do that, how to find the value of x by using a squared plus b squared equals c squared. Well, a and b would be the legs. So we know that 24 is a leg and 7 is also a leg. These sides are adjacent, which means they're next to the right angle. So I'm going to plug these in. 24 to the second power plus 7 to the second power equals c to the second power, or x. Well, then I just need to solve those. So 24 to the second power means 24 times 24, which is 576. 7 to the second power means 7 times 7, which is 49. Well, then I would solve 576 plus 49, which is 625. So I know that 625 is equal to c squared. Well, remember, if I want to find the value of c, and c is being raised to the second power, I would need to take the square root of both sides of this equation. Well, the square root of 625 is 25, and the square root of c squared is c. So that means that the value of this is 25. So since I have all whole numbers for these, I know that 7, 24, and 25 is a Pythagorean triple. For B, I see that I'm missing x, which is opposite of the right angle. Because it's opposite of the right angle, I know that I'm missing my hypotenuse, which means I'm given 2 of the legs. Well, I'm going to plug this into my formula, a squared plus b squared equals c squared. A and b are my legs, so I'm going to put 7 squared plus 5 squared equals c squared. Well, 7 squared is 49, 5 squared is 25, and I have all of this equal to c squared. Well, if I do 49 plus 25, I'm going to get 74. So I have 74 equals c squared. Well, to get c by itself, I know that I need to take the square root of both sides. I know that 74 is not a perfect square, which means that technically it's an irrational number. So I'm going to get a number that continues on forever and does not repeat. But when you look at your directions, it says round to the nearest tenths if necessary. Well, if I put the square root of 74 into my calculator, I get 8.60, which rounds to 8.6. So I'm going to say that this is about 8.6. Well, since this was not 3 whole numbers, I know that this is not a Pythagorean triple. For part C, I see that I'm missing side x, but x is adjacent to my right angle, which means I'm missing a leg. So I'm given one of my legs, and I'm given the hypotenuse. Well, I'm plugging all of this into my formula, a squared plus b squared equals c squared. Well, my leg is 10, and my other leg I don't know, so I'm just going to leave it as b squared. But this time I know that my hypotenuse is 20. Now I'm going to solve. 10 to the second power is 100. So this is 100 plus b squared equals 20 to the second power, which gives me 400. Well, we know that to solve this, we need b by itself. So this really is just an equation, and I need to get rid of my 100. So I'm going to subtract 100 from both sides of this equation. My 100s would cancel to leave me with b squared equals, and then 400 minus 100 gives me 300. Now to get b by itself, I know that I just need to take the square root of both sides. That's going to leave me with b equals, and I know that 300 is not a perfect square, which means it's going to be an irrational number that I'm going to have to round to the nearest tenths place. Well, when I put the square root of 300 into my calculator, I get 17.32, which I'm going to round to about 17.3. Now again, since these were not all whole numbers, I know that this is not a Pythagorean triple. For D, we see that we're missing another leg, which we know because it is adjacent to the right angle. 5 is a leg, and 13, since it's opposite of the right angle, is our hypotenuse. When we plug all of this into our formula a squared plus b squared equals c squared, I have a leg of 5, I have another leg that I don't know, and then I have a hypotenuse of 13. Well, 5 to the second power is 25, so I have 25 plus b squared equals 13 to the second power, which is 169. Well, when I solve this, I know that I need to subtract 25 from both sides of my equation. Well, my 25's cancel to leave me with b squared equals, and 169 minus 25 is 144. To get b by itself, all I need to do now is take the square root of both sides. Then I'm left with b equals, and the square root of 144 is 12. So that means that this leg has a side length of 12. Since all of these were whole numbers, I know that 5, 12, and 13 is another Pythagorean triple. Now, the converse of the Pythagorean theorem is when you do not know whether or not you have a right triangle. So in the converse, you are given all three side lengths, and you have to figure out if those three side lengths make a right triangle. Well, basically, all you need to know for that is if you can put the two legs and the hypotenuse into the formula a squared plus b squared equals c squared, then you are going to have a right triangle. So let's look at these examples. Decide whether these form a right triangle. Well, we can't go based on what these look like. We have to instead look at what are the two shortest sides. Well, my two shortest sides would be 8 and 15. So I would assume that these are the legs if this is a right triangle. And since 17 is the largest side, I would assume that this was the hypotenuse if this is a right triangle. So I'm going to plug all of this into the formula and see if it works. So my legs are 8 and 15, and my hypotenuse would be 17. Well, 8 to the second power is 64, and 15 to the second power is 225. 17 to the second power is 289. Well, when I add 64 plus 225, I get 289. Since I'm left with a statement that is true, I know that this is a right triangle. And since I know that it's a right triangle and I knew that both of these were the legs, I could come over here and I could put a right angle right here since I know that that is where it would belong. For B, we want to know if these would form a right triangle. We would assume that 9 and 24 were the legs. So we would do 9 squared plus 24 squared equals 25 squared. Well, 9 squared is 81. 24 squared is 576. And then 25 squared is 625. Well, we would do 81 plus 576. When we added those together, we would get 657. Well, since we have a statement that says 657 equals 625, we know that this is not a true statement. Because this is not a true statement, this is not a right triangle. For C, we know we have 23, 10, and 25. So we would assume that 23 and 10 would be our legs and that 25 would be our hypotenuse. So we would do 23 to the second power plus 10 to the second power equals 25 to the second power. Well, if we do 23 to the second power, we get 529. If we do 10 to the second power, we get 100. 25 to the second power is 625. Then we would add 529 plus 100 gives us 629. So now I have 629 equals 625. I know that that is not a true statement. So what this means is that this is not a right triangle. So it does make a triangle, just not a right triangle. D says 28, 45, and 53. Well, we know that 28 and 45 are our shortest sides, so they would be our legs, and 53 is our longest side, so it would be our hypotenuse. So if we plug that in, we would do 28 squared plus 45 squared equals 53 squared. Well, now we just need to solve these. 28 squared, if I put that in my calculator, is going to be 784. 45 squared is going to be 2,025. Then 53 squared gives me 2,809. Well, I would need to add 784 plus 2,025. When I add those together, I get 2,809. So now I'm left with a statement that says 2,809 is equal to 2,809. Since this is true, I know that this is a right triangle. And since it's a right triangle, I could put my right angle where it would belong, which would be right here. When you're trying to explain the difference between the Pythagorean theorem and the converse of the Pythagorean theorem, it's important to know that the Pythagorean theorem is used when you know for sure that you have a right triangle. You see the right angle, you know what the legs are, and you know what the hypotenuse is. We use the Pythagorean theorem to find missing side lengths by plugging into that formula. The converse of the Pythagorean theorem is used when you have a triangle, but you don't know if it is a right triangle or not a right triangle. So you know all of the side lengths, but you are going to plug them into the formula to see if those would make Pythagorean triples, which would tell you that you have a right triangle.